Today's presenters are Lucidworks CTO and Solar Committer Grant Ingersoll and Lucidworks Lead Data Engineer Jake Mannix. Thank you for joining us today, Grant and Jake.
Thanks, Aaliyah. And thanks, everyone, for joining us. As Leah said, my name is Grant Ingersoll, and with me is Jake Mannix. The way this is going to go today, we're going to kind of dovetail together, Jake and myself both talking, working through some slides on search and recommendations. So since we're starting a little bit late here, we'll just get through some of the preliminaries real quickly. If you're not aware, we are hosting Lucene Solar Revolution 2016 in October. So if the kinds of things that we're talking about today is of deep interest to you, then Revolution is the place to come be immersed in that for 4 whole days, all in Boston. Lots of great talks, trainings, chances to meet and talk with a lot of interesting people in the search space who are doing things just like you when it comes to search. As Aaliyah said, we're going to be talking about search and recommenders, and so with that, I'm going to lay out a little bit of an agenda here. We're first going to start off with some vision and motivation and a little bit of definitions by what we mean and how we think about recommendations. We'll talk a little bit about use cases, and then we're going to dive in on how Fusion, Solar, Spark enable these things and the evolution of recommenders as we see it. And then we'll finish up with a little bit of a demo and finally talk about where things are going forward from. In terms of vision, if you've been on any of my webinars in the past, you've heard me talk about this repeatedly, but I think time and time again, we just continuously see that this core technology of search allows us to do some really interesting things when it comes to ranking data, when it comes to thinking about what is most important in my data right now. And so you can apply that across a lot of different applications like the ones you see here. And if you think about it, recommendations also fits into that question of what's the most important thing that I should be showing my users right now. And so with that, we think that this platform that we have of Solar and Spark all wrapped together in Fusion really helps drive this next generation insight. To talk about that a little more, I'm going to hand off to Jake and we'll continue on.
Hey, okay, so just sorry, I was still muted, didn't want to interrupt. Right, so when we talk about kind of search and recommendations and discovery, we really like to see them as kind of, you can think of them as 3 sides of the same coin, right? There is what you can say as you know, the half of the coin that is search, and the half of the coin that is recommendation discovery are really both kind of using the same inputs, and they're actually using the same signals from your users to drive better quality. The relevance that you get at major sites these days, both in the B2B space and in the consumer space, comes from the engagement, the feedback that your users give you. If your users give you engagement signals telling you what's important to them, then what you'll need to do is stitch those 2 things together. You'll need to use the patterns of user behavior to show you know, what is important. In particular, patterns like popularity will show up at the simplest level, but really the signals are going to come together in a way that drive search relevance. They also drive, the exact same signals will drive recommender relevance. And in both cases, you're serving content to a user based on the data of the content itself, as well as the data in what the engagement happened. So let's go on to the next slide.
I think maybe a little bit of delay in the, we're on the next slide, Jake. There might be a little bit of delay in terms of screen sharing.
Not a problem. So when we're doing recommenders, you know, search is straightforward. You're issuing a query, you're returning results to the user that matches the kind of intent of the search. For recommendations, you're not really trying to deliver data to the user based on an explicit query. You're doing it based on kind of past behavior or what is relevant to the content you're looking at. And for the most of the rest of this talk, we're going to be talking primarily about effectively item-based similarity recommenders. So what that means is if you're looking at a piece of content, you want to see items that are related to that piece of content or similar to that piece of content that you could show as kind of related content. That is to say, it doesn't preclude doing kind of user-based recommendations, because if every user has preferences for a certain number of items, you can collate the similarities of items like each of those to kind of generate recommendations personalized directly to a user. That having been said, the way you measure relationship between items, similarity between items, comes in kind of effectively three different forms. There's content, which is saying that you've got textual similarity between different documents. It may have structure, it may not, it may just be kind of cosine similarity over the text space, but there's some measure of just textual similarity, not knowing anything about the behavior of users interacting with that content. And it may seem strange at first to say, let's not worry about the behavior of the behavior of users, because what about popularity? Well, the problem is that when you first start with a new piece of content that's never been seen by any user, you have this problem called the cold start problem that says this content may be perfect, but if no one's ever interacted with it, your system can't use popularity, co-occurrence analysis of clicks. It's got no engagement, but it may still be useful. So content-based recommendations kind of overcomes this cold start problem by saying, what is it textually similar to? The more familiar form of recommender systems that people hear about is the collaborative filtering style of recommenders, which says users that bought this also bought this. Users that clicked on this and this and this also clicked on these other things. And that says that items are similar if similar sets of users clicked on them or engaged with them in some way, whatever your business case engagement signal is. But what I like to think of is content-based recommenders and collaborative filtering-based recommenders as just 2 points on a spectrum that interpolates kind of smoothly between the two. And this is the third way of measuring similarity between items for whatever your item type is. That is multimodal. Take a little bit of content-based similarity and a little bit of collaborative filtering-based similarity and mix them together. You can then A/B test them and see which one matters, which one's better. You may even have a parameter that gets tuned based on what their users' history are. It could be, there's many different things you can do here, but the point is that you can kind of interpolate between content-based recommenders and collaborative filter-based recommenders, both of which have different pluses and minuses.
Great.
I think the next one's you.
Yep, so great. Thanks, Jake. With that, now that we've kind of got some of these definitions out of the way, what we're going to focus on is some use cases across a few different industries, and then we'll take this idea of content and collaborative recommenders and multimodal, and we'll talk about how these get deployed in Fusion. In terms of use cases, I think most people who haven't been living under a rock for the past, 10, 15 years are aware of the online retail use case, whereby, you're taking things like people who bought this, bought that. And so, I think that's a pretty well understood use of collaborative filtering. The interesting thing is when you start to look at how to do this multimodal approach in online, you have a real opportunity to shore up the shortcomings, if you will, of the collaborative filtering approach by having it backed by a search-based system such that you can fall back on content-based recommendations, or as we like to call it sometimes, plain old search. And so for that new content, for the content that users haven't necessarily interacted with a lot, you can leverage the content-based recommendations. We'll talk a little bit about what that means here shortly. And then you can start to overlay and capture the collaborative filtering-based approaches as well. And really, bringing those together can provide the best in class when it comes to search and recommendations. And this is something that we're seeing out of our best in class e-commerce customers at Lucidworks here, is people really taking and driving the whole browse, navigation, discovery, and search experience all off of the same platform, because let's face it, the data that drives better search is also the data that drives better recommendations, better auto-suggest, better spell checking, better facet selection. All of that data is very similar in nature, based off of clicks and add to carts and signals that users provide to you. And so that can be a really interesting use case, and probably the most visible and effective use case for recommenders. Another one that's perhaps a little more subtle and interesting is we're starting to see especially in financial institutions and highly regulated institutions like in healthcare, people leveraging search and recommendations to help drive a deeper understanding of compliance and surveillance. And, you know, I think about this as being yet another arrow in the quiver, if you will, in that it gives me yet another way of looking at what are the patterns of how users are interacting within the system. So in some financial institutions and other companies that we've been working with, they're not only taking all of the data like email and Bloomberg chats and instant messaging and perhaps social media activity or phone activity. They're also overlaying with that information they have about what people are doing within the organization, what files they're sharing, what rooms they're using within the offices, and trying to correlate behavior with bad actions, if you will. Obviously, this is a needle in the haystack approach, but the idea here is by surfacing this kind of dashboard and related information out to your compliance officers or your surveillance officers, it gives them an opportunity to make more informed decisions about what's happening in the organization. So this is not necessarily something they're monitoring all the time, but once they have an active investigation underway, this is something that gives them deeper insight into what is going on. And again, so it's in this kind of idea, the recommendations really are, you know, people who behave this way also behave that way, right? So trying to correlate user behaviors, in particular then detecting the anomalies and the bad actors and trying to figure out what are the commonalities there. Last but not least, and this is in some ways can be thought of as very similar to e-commerce or online retail, except for here what customers are buying is they're buying support or customer service. And the interesting thing on the customer service side of the equation is that it tends to be that the case that the queries and the interactions are much richer. You're often dealing with users who are perhaps dealing with a lot of unknown. They perhaps don't know how to even describe the problem they are having. And so by using recommendation capabilities, by looking at the path that previous users have taken when they've asked similar questions, overlaying that on top of your content, the multimodal recommendation approach can be a really killer application for customer service. And from that, you can drive things like alerts and you can drive a lot more self-service support, which I think, you know, in most organizations is one of the major driving goals of a customer service organization, is you want your customers to be able to help themselves as much as possible. So those are just three of the high-level use cases. We obviously could spend a whole webinar just talking use cases for these things, but I wanted to at least give a taste of what we're seeing in our customer base around how people are driving this multimodal recommendation and search engine capability. So with that, let's get in a little bit at a little bit lower level and talk about how Fusion, how this product that we have that combines Solar and Spark delivers on this multimodal vision around recommenders. For those who aren't familiar, just provide a little bit a quick brief, you know, at the high level around what Fusion is. I think there's really three key pillars when I think about what Fusion provides. The first, we're really after driving this notion of next generation relevance in Fusion. I think if when most people think about search, they think about keyword matching. If you're a Solar user or a Lucene user and you've been doing this a long time, you know that those technologies are very good at kind of the keyword matching capability. But I think many people also recognize that only gets you so far, especially in environments where you have lots of user interactions, like e-commerce or like consumer support or any of those kinds of spaces. And so when I think about relevance, I like to think about it as the 3 C's. You know, content, this is the core product catalog, that's your core data. The keyword matching, your token analysis, your stemming, all of those kinds of things. The second C really is collaboration, and that's a lot of what we're talking about today and overlaying on search to provide this multimodal experience. And this is all about how are users interacting with the data. What are they telling you? That's obviously not the entire picture, but it's a pretty important picture because let's face it, if a particular document satisfies a user's need, then it's more than likely that the next user who comes in and has that same need is going to want that document as well. And then the last C, context. This is all about who is this person, where are they, what are they doing, you know, what is the season, what is the weather, whatever information you have in your system that you can take advantage of to, in a sense, personalize the results. And so at the end of the day, I like to think about mashing all of these things together. And to Jake's point earlier about thinking about this as a spectrum of results, you know, we could turn up the content side of things if we want. We can turn down the context side. We can turn up or down the collaboration side. And really at the end of the day, this is what that search engine is really good at, is mashing these things together and saying, here's what's important according to some notion of importance. The second part of Fusion, to beat the drum that we have been for quite some time, is we want you as developers to be able to harness best-in-class open source. And for us, that's Solar and Spark. This allows all teams and companies and developers to leverage all of the open knowledge that is out there and available in the on the internet for learning and deploying these kinds of things. And so we want to make sure Fusion deploys just like that. Last but not least, we really want to simplify ongoing maintenance and development. The architecture for Fusion looks like this. On the right-hand side, that's all of your open source bits. In the middle, this is what Fusion adds as a value on top of those open source bits. We provide out REST APIs, we secure the whole thing, etc. Kind of another take on Fusion, if you will, is I like to think sometimes about Fusion really being about how do I ask more interesting questions of Spark and Solar. You've got a ton of data in those two open source systems. Let Fusion help you drive the questions you can answer it with it. And one of those key answers is how can I drive this thing called recommenders or recommendations or discovery off of a search engine. And so with that, I'm going to hand it back to Jake, who's going to jump in on the key platform ideas and take you at a little deeper level about what's going on.
Okay, so we're going to talk a little bit about what's kind of under the hood of what kind of stitches, what kind of holds Fusion together, and how does it do recommenders. Now, at a high level, Lucidworks Fusion exposes kind of a couple of key pieces. A recommendations API, which primarily is based on the user engagement, the query engagement signal aggregates. So behind the scenes, Fusion is scooping up and aggregating over in a configurable way your kind of clicks and cart ads or support tickets or whatever your engagement signals are, and kind of aggregating them on user item query triples, and you maybe time discounted and so forth, and generating these aggregates. It exposes this recommendations API exposes a REST API on top of these engagement signal aggregates, and provides some nice kind of high level verbs for recommenders. Most recommenders will kind of find these kind of things familiar, especially if queries are involved in a search world. We are. You can do things like items per query, where you get items for users you get items that were best found for a given query. You feed in a query input, it returns what your users thought were best items for that query. You can also do the reverse. There's an API for give me queries for items. Give me the queries that are most likely to have led to engagement with this particular item. So it's kind of inverting your engagement and seeing where did the queries come from to engage with this item. It's a good analytics piece for developers and data scientists at your organization. And then there's the thing that is what we think of primarily as a recommender, which is items for items. Get other items that are likely to have been found by queries which led to this current item. So it's kind of a bit of a leap to kind of imagine what it's doing behind the scenes. We're going to talk about that in a little bit. But point being, the Recommenders API just kind of exposes this as just a REST endpoint that you can just talk to the system and query for each of those things. Beyond that, if you want to do more than just kind of do the simple aggregations, you're going to want machine learning to do the things that kind of really push the envelope. This is new in the most recent versions of Fusion, where we allow you to script together both index pipelines that have machine learning components inside them that would do kind of things like classify incoming documents by product category on the way into the index. Or if you're indexing tweets, label the tweets as they come in by sentiment. So you're doing this on the fly at index time, not later as a big batch process. Or, spam filter incoming mail messages. You can also use machine learning pipelines in Fusion at query time, where queries will come in and you can do you could set up a pipeline that does query expansion to find related words for the incoming query, or query intent classification. And of course, kind of whatever you can find, a use for stitching in your machine learning code itself into either the query or the indexing pipeline, the sky's the limit. And then the kind of last piece that kind of helps, stitch together, both machine learning and recommender systems inside of Fusion is a way to schedule these things. Because getting one-off code that you just build once is not something that's going to, work in enterprise or any production environment. You want to be able to schedule batch jobs anywhere from the simply configured, signal aggregations where you just kind of take your time decay weighted sums of engagement counts, all the way up to custom handwritten Scala Spark jobs that do whatever you can imagine, both on your primary index as well as on the signal aggregate indices or the raw signals themselves. And you can schedule them for whatever intervals. You've got a nice UI to handle that. So that's kind of what Fusion provides. Under the hood, of course, it's backed by Solr and Spark. Solr, of course, is going to provide from beyond search, it's going to provide this level of recommenders that comes kind of pretty much out of the box, which people don't really think about when they think about Solr. But the more like this query handler for Solr explicitly will do, given a given document in your index, find other documents textually like it. We'll go into that in a little bit more detail in a minute. And then Spark, of course, ships with Spark's own MLlib library. But we also bundle with Fusion Apache Mahout that runs on Spark as well. So you've got kind of a whole slew of classifiers, item similarity matrix building tools, and even things like alternating least squares, collaborative filtering recommenders, a fair amount of stuff that you can get out of the box just in the open source world bundled with Fusion that runs on Spark for you without really writing any math. Of course, if you really do want to write math, I like math personally, you can just write your own jobs and those will run inside of the system as well. Let's go on to the next slide. So I kind of glossed over how Solr can provide content-based recommendations out of the box, but let's go into a tiny bit more detail. What it really does is it has this query parser, which is the more like this query parser, which just takes a document ID and says, okay, I'm going to fetch the non-trivial terms from the fields that you specify in it. So for example, if you look at the bottom of this slide, it says we're using the more like this query parser, and we want to take similarities based on the field of the body, the suggest field, the subject, and the title. And what we want to say in terms of what is a non-trivial term, we want terms that occur at least twice and have, at least 5 occur in at least 5 documents throughout your index. So not too rare, and at least twice. And then a minimum word length of 3, so you don't get these super short words. Then it builds a big OR query over those and computes effectively a cosine similarity between the other documents by querying against the index. It's not exactly a cosine similarity, but it is a vector space similarity that uses the TF-IDF that underlies the scene. You've got a bunch of knobs that you can also tune for data cleaning away more of non-useful terms, which often can tend to be important, especially for large documents. So this TF-IDF similarity that Solr comes kind of out of the box is pretty fantastic. But if you're doing content-based similarities, you don't have to stick with just more like this. Although, frankly, if you try it, you may find that it really kind of works. Maybe it's your 92% solution, and yeah, you can get a 97% solution by doing something fancier, but is that extra 5% worth the amount of effort? If you've got the time, you've got a data science team that wants to do it, you can use, latent semantic indexing, LDA, Word2Vec to kind of find other ways of getting content-based similarities and use those for doing, your content-based recommenders. And that'll work within Fusion as well. That's just going to require more work. Depends on the use case. So on the next slide after this one, I'm going to kind of talk about in detail what the kind of Fusion, the Lucidworks Fusion query pipeline is that does this kind of on-the-fly collaborative filtering recommendation. But before we get into the details, let's think about what is kind of the big picture. What is the simplest possible engagement-based recommender system that satisfies the criteria? It does something like people who bought X also bought Y, or movies for you based on things you've watched in the past. What does it look like? Well, the first thing is, behind the scenes, you've got to be kind of generating this user item kind of preference matrix, this user item index that says, here are the items that we know certain users already enjoy to some degree. Maybe you've been aggregating the clicks, maybe you've been aggregating other signals, maybe you have another system that already generates this stuff, knowing that they spent this much money on a certain item. But whatever, at the end of the day, you have this index input that tells you what you currently know about users and their preferences for certain items. So if you want to generate new items for them based on this past information, you want to build a similarity metric between the items in this user item index based on these engagement signals. So Fusion provides some tools to do this kind of on the fly, where you don't pre-compute anything, as often as that may be useful. This just given user item preference index, it's kind of a multi-stage process. So first you've got a current document. Let's kind of go from left to right across this workflow, which roughly speaking correlates with the index, the query time Fusion stages. First you've got the current document ID. You query into the user item index for that item. And you fetch the top K users who have interacted with that item based on the preferences. You've got these K users that all find that item interesting, and now you do a kind of a fan-out query, where you query back to that same index and say, for each of these users that really like this item, get me other items that they also found interesting. Out of those, you want to collate those up by kind of grouping the duplicates together, summing their weights, or doing some other effective inner product, and you'll get a top Y documents out of that full fan-out set of the items that the users who like this item also liked. And at the end of the day, filter out by context. Possibly there were queries involved in some of your signals. And maybe you want to say, I only want to show results that were relevant to a given query path. Or maybe you've just got other filters that are applied based on business rules. But at the end of the day, you've used the raw user item index and a simple kind of two-hop across the user item, preference graph, if you want to think of it like a graph, a two-hop kind of fuzzy cloud around the current document to generate a similarity metric between documents that returns similar items based on the user preferences of your system. Okay, so step by step, we gave you the picture form while I kind of talked through the fan out of these queries. But the nice thing about what we provide in Fusion is kind of a way to just configure those stages as opposed to having to write them all yourself, yet they still allow for a lot of flexibility in terms of what you mean by similar and what you mean by preferences. In particular, those kind of 4 stages we saw on the previous page end up being what we call a subquery stage. We start with the incoming query is I want items relevant to this current document, similar documents based on collaborative filtering. And what it does, it takes that given document and it searches the signals index using the current document ID and extracts the top K pairs of the kind of preference weight and the user ID who had that preference for some other item. Oh no, for that current item, sorry. Armed with those results, generate a big weighted OR query using those weights. And if you're familiar with Lucene syntax, even though we're doing kind of collaborative filtering, this is backed by Lucene. There's no real textual similarity here. Here, our similarity is using the weights that we've computed offline based on the engagement signals. So syntactically, it looks exactly like, and of course under the hood, it's working exactly like a textual query, but it's not really doing text, right? It's looking for user IDs that you found in the first stage. This subquery will try to return more documents from that same index together with their preferences that were based on the users found in the first stage. Now the fourth stage we just kind of group all these things together and take the top n for each item I, take the score you got from the previous subquery stage, multiply it by the weight you also got. Now this is where you're getting a dot product effectively. Sum those up and then take the top n over I of the items. And these are the similar items based on effectively a cosine similarity of the engagement preference graph, engagement preference matrix. Finally, once you've got these items, you've got document IDs, but you don't want to return just document IDs. You want to return the documents. So you go back to Solar again on your main index that actually has the data for these documents, fetch them out, and pass them back to the user. So let's wrap it all up. If you've got kind of this more like this or more like this plus content-based similarity, and you've got this collaborative filtering-based similarity, the thing that is similar, haha, pun intended, between these two approaches is they both are taking a document-to-document matrix and generating a distance metric, or conversely a similarity metric. And they're using different things to generate that document-document similarity matrix, either engagement signals or content similarity, content cosine similarity or something like cosine similarity. Content is using features for the similarity based on the tokens of the document, and collaborative filtering is using the user IDs and their preferences. But metrics in general, and anytime you've got a set of items that have a metric distance between them, you've got a metric space. Metrics can be summed, and you don't need to just take a sum of two metrics by just saying, distance 1 plus distance 2. You can of course take alpha times distance 1 plus 1 minus alpha times distance 2 for any alpha between 0 and 1, and that allows you to kind of smoothly interpolate between the two of them. So that's kind of the straightforward way, the approach that I kind of tend to advocate, is that it allows for a nice, easy understanding of what you mean by a multimodal recommender. you take a little bit of content similarity, a little bit of collaborative filtering similarity, and you can kind of slide between the two of them. And you can actually see by setting a parameter where you are on that spectrum. But it's not the only thing you can do. At the end of the day, you really can, once you realize what you're doing is generating a similarity metric on your space of documents, you can, and you've got features like the tokens, and you've got features like the, token counts and the user ID counts with preferences. You can do any sort of fancy similarity technique on that space you've got with all those features. You've got tokens and user IDs as your kind of feature sets, but you can even do a joint similarity metric where you take for each document ID, it's got a set of tokens and a set of user IDs. Consider them together as one big vector and generate a similarity metric or some kind of SVD on top of that matrix, using all features together and trying to learn a correlated distance metric. The cost of doing that kind of thing, of course, is that for all its fanciness, is much harder to maintain, much harder to understand what's going wrong when it goes wrong, because sometimes it will. And it's harder to kind of A/B test variations. In really big enterprises or really big spaces with really big data science teams, this is definitely the kind of thing that will happen. You will want to have a more fancy similarity metric, but just be aware that when you see talks and see people describe ways of doing this in a very fancy way, similarity metrics that are fancier than a slider between two very good approaches are the point of diminishing returns for the cost of investment sometimes. But don't let me dissuade you. Try it yourself. It can be pretty powerful at the end of the day.
And Jake, just maybe before we get into the demo, one of the things I think we often see is, customers, we kind of encourage them to think about, building up on top of these things. And so things like the content-based, more like this recommender, is super easy to deploy. And then, for instance, you can start to overlay signals and kind of click-based query boosting on top of that, more like this. And then on top of that, you can then start to add some of these broader collaborative filtering style approaches. And so it's very much possible to kind of build out, go from, crawl to walk to run as you think about deploying these things. And the really nice thing is all of the data that you need to know and understand what's going on here, you can leverage as part of this process. So with that, I know we want to continue on. We've got a little bit of demo for people to look at that shows some of these ideas at the surface level. And more importantly, we actually have code available for people to try out. So I'll give you a link here in a second for that. But the first to describe the demo, if you saw earlier in the week, we actually just put up a blog post on our website around what we are calling Search Hub. Search Hub is a community site that we put together around Apache projects that we like to work with or just thought were interesting or thought people might want to engage with. You perhaps, if you've been around Lucid for a while, you know this perhaps as Lucid Find. We now call this Search Hub. At any rate, in beta, we've launched searchhub.lucidworks.com. I would encourage you to go check it out. It is a beta. We still do have some bugs in there, of course, but we are working through them. Most interesting thing about Search Hub is we really had a number of goals in terms of making this available. First off, we wanted to have a community forum that people could engage with, the Apache mailing list, websites, etc. But we also wanted a showcase for Fusion. We wanted to show what Fusion was capable of, not just at the search level, but for things like recommendations, things like signals, things like security, and all of those aspects. So a little bit of the details about it. So far, we've got 26 Apache projects registered and indexed, and that includes their email list, their in some cases their GitHub repositories. It includes their websites. It includes their wikis. Basically, kind of the main content about that project is indexed and searchable. Additionally, we have put in a bunch of our Lucidworks knowledge base information, our blog, et cetera, so that we can kind of interweave our content, our technical content with the Apache content to make sure people, especially in Lucene and Solar Land, are getting a complete picture. As of now, it's roughly 90-some data sources spanning what you see there on the slide. It's running on Fusion 2.4.1, so basically the latest released version of Solar. Most interestingly, we have signals pretty much everywhere on the application. We quantify what people are searching for. We quantify what they're clicking on. We quantify what they see on the page. We quantify how they interact with auto type ahead, auto suggest. We quantify things like time on page, all using the Snowplow JavaScript tracker. So this really serves as a way for customers and people to see how to enable signals in their application by giving a working demonstration of that. It's all built on our new UI product called Lucidworks View. And we've also put up a mirror of the archives for people if they want to try this out, just so that they don't get banned from using the Apache website. So if you want to try it out, you can go to our GitHub. The link is at the top of the slide there. Master, of course, contains the information that is running on production. So that's what you would see at searchhub.lucidworks.com. The work for this webinar, we have not deployed live yet. We are still testing and developing it. But you can see all of that, all of what we've been doing over the past week or so in building this out on a particular branch called GH28DocView. And that ties into the GitHub issues there, so you can see all of the work that's going on there. In terms of the implementation, we've been doing a number of things on top of Fusion. So we're leveraging Fusion's plugin points, and we're leveraging the View UI, highlighting a few of these items that put the names of particular objects that are on that branch that people can then go and check out. Right now, the way we've got this implemented is, and I'll show you here in a minute, you do a search, you click on a document, and once you click on that document, it kicks off that process that Jake was talking about earlier. Namely, in fact, what we're doing is we've actually built up 3 different pipelines to showcase a couple or 3 different ways of doing recommendations. So what you see on the left-hand side here under Fusion Pipelines, we've got 3 pipelines, one for doing the more like this style recommendations, one for doing what we are calling pre-computed batch recommendations, and then the last one is an online one. And so these kind of tackle some of the main ways people go about building these different applications or these different recommendation systems. And then as we finish this up and actually deploy it live, we will also be deploying that slider-like capability, that spectrum chooser, if you will, so that people can play around with the results and this multimodal slicing of the data. So that's the query side. On the back, if you recall, Jake talked about there being this offline process where we're building this user item matrix. Those are both Spark jobs. The very first one, we go and create signals off of, and Jake can correct me if I'm wrong here, but one of the ways we're looking at how people are engaging with the content is by actually looking at the mailing list information and looking at who's replying to what content, and we're using that as a measure of signals, as a measure of engagement. So if you've replied to an email, that's a signal that you care about that item, much like a click or some other user behavior. So we're using that to bootstrap our user item matrix. And so then we've got 2 different ways of doing that. One is building the user item matrix for online querying. And then the second way, we've actually put together a pre-computed approach that goes through and pre-calculates a lot of those interactions. And so there's trade-offs there in terms of speed and performance and so on and so forth. Last but not least, we've added a couple of UI components, Angular directives, if you will, that know how to interact and display this content. I would encourage you, github.com/LucidWorks Search Hub. All of this code is available. There's nice, easy instructions on getting it up and running and crawling the mail, data sources and the websites and all of that kind of stuff. And it should do it in a polite way so you won't get kicked off of any of the Apache resources. But I would encourage you to go check that out. This is something we will be making live here in the future. So with that, I've covered the live side of things, and I've covered we've talked a little bit about the ensemble and click-based approaches. One of the other things we're going to be adding to this site soon is the ability for users to register. And so we envision then that we can start to send you recommendations for content that you might be interested in. We can send you alerts. You will also be able to simulate it as if you were a particular user and seeing, interacting with that community, what their recommendations are as well. So, Jake, I don't know if you had any more thoughts on the future work. Otherwise, I think in the interest of time, we have time for. We got a little bit of a late start. We have time for a couple of questions, and we can continue on from there.
Sounds good.
So, Leah,
okay, so we will,
if you want to kick it off?
Yep, thank you. So we will do just a couple questions. Again, if we don't have time for your questions, someone from Lucidworks will reach out to you. So the first question is Spark installed with Fusion, and does Fusion support Solar Cloud? Can I run a Spark cluster with Fusion?
Yeah, I can take that, Jake. Well, yes, Spark comes with Fusion. We run it right alongside Solar, and in fact, we run it right along Solar Cloud. This is all built off of the Spark Solar project that we as a company have built and open source and maintained. This is something that we've done a lot of work on in order to make sure that it's very highly performant. We take a lot of advantage of Solar Cloud and data locality and our knowledge around what kind of data types make for fast, efficient queries. There, of course, is always more work to be done here, and so we encourage people to check out that open source project. But this is, in fact, one of the beauties of this system. Download Fusion, hit start, and you've got a Spark Solar cluster up and running, including and this is something I've really come to appreciate over the last few weeks of building these kinds of applications. You have Spark Shell available to you. So you have a command line environment where you can try out Solar queries against using Spark against your Solar index. In fact, Jake and I have both done several talks at various conferences that show this in much greater detail.
Thank you. So we'll just do one more question. We're just about out of time. This question is the slider more like search or more like a collaborative filter? Is this runtime changeable to compare systems with different slider settings?
Yeah, I think I can take that one. Slider is saying, let's see, more like search? Yeah, I think I would say it's more like a search where your search query is the current document itself at one end, and more like collaborative filtering at the other end. And the slider would be a query. It could even be a query parameter. In fact, it would be implemented as a query parameter behind the scenes. But in our kind of demo product, in our community product Search Hub, it could actually be an even literal slider in the UI, where you actually, the user on the page, this isn't something you would do this for your customers in a production environment, but in our environment where we're trying to kind of show different aspects of similarities and recommenders, we'd have a literal slider on the details page that Grant was demoing before, where you could say, hey, here's the multi-modal recommender, and there's a little slider on it, and you say, okay, slide it from one side, you go all the way over to one side, and you get exactly the results that are in the panel above. That's the collaborative filtering one. You slide it all the way to the other side, you get exactly the results that are the content-based, more like this recommender. And anywhere in between, you're going to get some mix that maybe even results that appear in neither of the two. So yeah, it's an actual slider between search like the current document and collaborative filtering and similarity.
And of course, just to add real quick on top of what Jake's saying is in a real production system, this isn't something you would show, as Jake mentioned, but it's actually something you can tune yourself as a search developer, or perhaps it's even something that you capture information about what matters most. You run different experiments to see what weights work or how much you should weight any particular one. And you might even change that slider value depending on the type of query the user is asking. So if it's more of a known item search, you might gear it more towards more like this, or if it's more of a categorical or conceptual search, you might gear it more towards what people care about. And so this, again, is kind of this beauty of a system that is able to capture and learn from the feedback that your users are giving you.
Great, thank you. So we are definitely out of time. Thank you so much for sticking with us till the end and through the technical difficulties that we experienced. Everybody who registered for the webinar will receive a link to the recording. So if you missed anything or you want to watch it again, you will have that chance, as well as a link to the slides. Thank you so much, Grant and Jake. You guys did great despite the issues. Hope everyone has a good day.
Thanks, Olivia. Thanks, everyone.
Thanks, yeah. Thanks, everyone.
Thanks, Olivia. Thanks, everyone.
Thanks, yeah. Thanks, everyone.
Thanks, Olivia. Thanks, everyone.
Thanks, yeah. Thanks, everyone.
Thanks, Olivia. Thanks, everyone.
Thanks, yeah. Thanks, everyone.